How many number of oxidations occur in aerobic respiration per one glucose molecule? There are 6 oxidations. 1 in glycolysis, 1 in between glycolysis and Krebs cycle, 4 in Krebs cycle. Total it is 6 oxidations. Next, how many coenzymes which are involved in aerobic respiration per one glucose molecule oxidation? The 12 coenzymes which are involved. Out of which 10 are NAD coenzymes, 2 are FAD coenzymes. In these 10 NAD coenzymes, 2 that belongs to glycolysis, 2 between glycolysis and Krebs cycle, that is pyruvic acid to acetyl coenzyme A, and 6 in case of the Krebs cycle, a total of the 10, and 2 FADs2 in case of the Krebs cycle. Next, how many redox equivalents are removed for one glucose molecule in aerobic respiration? As 12 coenzymes are involved, each coenzyme, the 2 redox equivalent, so total 24 redox equivalent, 24 hydrogens which are removed from the respiratory substrate. Next, how many oxygen molecules which are required for the oxidation of the total reducer coenzymes for one glucose molecule? For one glucose molecule, there are the 12 reducer coenzymes. The 12 reducer coenzymes for its oxidation require 12 oxygen atoms. That is 6 oxygen molecule. How many metabolic water are formed at the end of the terminal oxidation? And the 12 coenzymes are involved. These 12 reducer coenzymes, the oxidation required 12 of O2, that is oxygen atom, results in the formation of 12 water molecule. That is one part. As each NADH2 on oxidation is going to contribute the 3 ATP, 1 FADH2 is going to contribute the 2 ATP. As 10 NADH2 are formed in case of aerobic respiration, so total of 30 ATP for oxidation of all NADH2 coenzyme. In FADH2 coenzymes, the 2 FADH2 coenzyme, 1 FADH2 on oxidation is going to contribute the 2 ATP. So 2 FADH2, 4 ATP. So for NADH2 30 ATP, FADH2 4 ATP, and 34 ATP formed due to oxidation of all reduced coenzyme. Aerobic respiration lo erpadina mottamu reduced coenzyme oxidation jarugute vacheti ATP lo, that is 34 ATP. So how many total ATP molecules formed in aerobic respiration per one glucose molecule? That is, per one glucose molecule, as 34 in oxidation and 4 ATP formed in case of the glycolysis for each G3P2 ATP molecule, 2 G3P 4 ATP molecule, 34 plus 4, 38, and in 2 terms of the Krebs cycle, the 2 ATP form, so total it is 40 ATP. So net gain of ATP in aerobic respiration, as in first and third reaction of the glycolysis, glucose to glucose 6-phosphate, fructose 6-phosphate to fructose 1,6-biphosphate, there is an investment of the 2 ATP, that is fructose 6 glucose to glucose 6-phosphate, fructose 6-phosphate to fructose 1,6-biphosphate, the 2 ATP which are invested. So a net gain of ATP is going to be 38 ATP. So total it is 40, net gain is going to be 38 ATP, only oxidation it is going to be 34 ATP. Some of the question it is like this. How many net ATP formed in glycolysis with involvement of oxygen? So naturally there is a question, there is no oxygen involvement in case of glycolysis. But the process never occurs one after other, it is simultaneous. Whatever the NADH2 form, it undergoes oxidation, is going to yield the 6 ATP, the 2 NADH2. As net gain of ATP in glycolysis is the 2 ATP, and oxidation of NADH2 6 ATP, then it is going to be 8 ATP. So net gain of ATP in glycolysis, it is the 2 ATP. Net gain of ATP with involvement of oxygen is going to be 8 ATP, like this. You will see number of questions in next videos. Thank you.